Hi, my name is Bennie Kirk. I'm a volunteer at the Austin Steam Train Association. Mostly volunteer in the yard, and our job in the yard is keep all of that running. Maintain the trucks, maintain the cars, and everything you see back here needs maintenance work and being fixed. One of my pet projects working down here is our renovation of a baggage car to a power car. This is our baggage car. What we're doing is we've taken this baggage car, we've stripped everything out of it, started from scratch, rebuilt the floor, added in some conduit. We're making it so we can have a generator in here, and this will supply power to the train as we go down the track. To understand why we want this power car, next stop's going to be the Maurice Beckham. We'll show you what we currently are running, and then we'll show you what we want to go to. All right, talking about the Maurice Beckham, and here it is right here. We talked about this on episode 1. I'm going to give a slight recap just to make up for the sound system and people who maybe don't remember episode 1. I also want to mention that we are going to have a future film telling all the history and more details of the Maurice Beckham. The thing I want to go into right now is the generator. This generator here puts out about 140 amps, just to give you a rough number, and it drives 6 cars, and that's the limit. If you add one more car, this engine will not provide the power to it. So the purpose of the power car that we're reconstructing right now is to get 4 times more power, because it's about a 10 times larger engine than what we have here, because it's not stuck underneath undercarriage of a car. It's actually sitting in its own dedicated car. Right now, as you notice, we have the Cummins 19-liter engine already in this car, locked down and bolted in, ready to go. So let's go on upstairs and look at it. Now we're in here. We can see we have the generator in here, mounted on its dedicated rails. Getting in here was fun. We had a lot of planning. This thing, everything was drawn up on my CAD system before we even started. Everybody was briefed before we even started. So we had 2 teams, one team inside, one team outside, all oiled up, ready to go, which made this move real smooth and looked like we knew what we were doing. What we did is took the flat car, hooked it up to the other side of this car, did some cribbing and some wood, put some metal plating on top of that, took some metal round stock bars to make it easier to move, rented a big telehandler to set this onto the bars, and then we used come-alongs and chains to drag this about 5 inches at a time until we get it on here in one piecemeal motion. It's now bolted down and ready to go. As you notice, the Maurice Beckham fit underneath the car. This one barely fits inside this trailer, and it is 4 times bigger than the Maurice Beckham generator, so it creates 4 times as much power. We can drag a train 4 times the size of the one we got right now. For instance, we can go from 6 cars to 24 cars and not even sweat it with this guy. And it's hard to believe that this was in the nose of a locomotive at one time. These big outriggers were cut off. The whole thing was just kind of tossed out on the ground, and we picked it up and rebuilt it and got it ready to go, and are going to use it for the Austin Steam Train power car now. On this side, all temporary. This line here goes to a 5-gallon bucket of diesel that sucks fuel into the car to running on, and this other one is the injector output fuel. So we just catch both of them and keep them going and swap buckets when it gets empty. We have the wiring from the controller over to the generator that controls everything and gives us the ability to monitor everything that's going on as far as our temperature, oil pressure, and generator function. Back here we have Joe Perro. Joe, would you like to tell us what you're doing today?
Hi, I'm Joe Perro. I'm a volunteer here. I've been here about 2 years. I am originally a respiratory therapist and did that for 45 years and worked in the medical industry. Don't live too far from here, and I just wanted to do some volunteer work. Rode the train back when I moved into Austin back in the early 2000s, and I enjoy working with bigger stuff, mechanical stuff. Never done that really in my life. So I enjoy working with the guys here and the whole crew and all the volunteers and the executive committee and just everybody. So what I've been doing here in the car, other than painting the car, we probably painted this side of the car first, is that our brake system, which is our handbrake, was on the outside of the car. Well, there's no place really to stand outside for our brakemen, so we're turning it inside and bringing it so they can use the handbrake from internal. Basically what I've done is I cleared this all off. This used to have a bunch of stuff on it, and I scraped it all down. I am now preparing it to prep it with a primer, and then where I have this sealed, I'm actually going to bondo the back of it, and these holes here was where we would be re-putting this brake back on. We are going to completely clean it out, get it recertified so it's good for many years to come. So that's what I'm doing right now.
All right, on this side, we have the starter hooked up here so we can start it remotely. We don't have a radiator, so this is the radiator input pipe. Up here is the radiator output pipe. So we just kind of make sure we have water in the pipe before we start it. Make sure it stays cool. This is the air intake just coming out of the car right now, and this is the exhaust. We have a temporary tailpipe just taking the smoke to the outside of the car. All right, well, I was going to talk about this, but they're making noise back there, so let's go talk to them. Can you pan and follow me? Okay, being they want to make noise, stop making noise for a second.
Okay.
This is some more of our volunteers. I'm going to pass the microphone around, let each one of them tell you who they are, what they do in real life, and what they do here at ASTA, and why are they here?
Hi, I'm Chip Carter. I've been in the engineering field of electricity for a lot of years, and retired, and now working here on heavy stuff that I never touched before, and with some good guys. So here, Mark.
Mark Starkle. I'm retired as well. I was in sales my entire career. My father and two of his brothers and grandfather were all railroaders, so I thought it'd be kind of neat to learn what they were doing. So we're in the process now of making some doors for the generator car.
All right, some of the history on these cabinets. The generator and these two cabinets at one time are in the nose of a big locomotive. When they were retrofitting that locomotive, they cut all of this out and just kind of threw it out on the ground. When they disconnected the wires from one cabinet to another, they just got into the terminal strips and just cut them, and made it a little bit more difficult to figure out how to wire it back up. Same way with all this going on the floor on this side over to the generator. They just cut them, opened the cages on the side of the engine, and kicked them out. So part of the fun and games is coming in here and figuring out what everything originally did, and then how we can put the two cabinets back together and get them wired together correctly. Each one of these relays in here is a safety relay that monitors like oil pressure, OPR rate, water temperature, head-end power, so low water. Every one of those relays is a safety feature that if we have a fault on the generator, this will open up the big relay and shut down the generator. This was the original governor for the engine, but it wasn't really working. So I bought a new 20th century and added a power supply because it wants to run on automotive 12 volt rather than the 64 volt this system is set up to run now. This logic down here, this is our ground fault. These are over voltage, over frequency, all of the AC safety features. This box right here is the regulator for the generator to set up the 480 volts. So this makes 480 volts. This makes 60 hertz. And then I've got this box I added, which just tells us which relays are closed, which relays are open, and what faults we may have. Oh yeah, the panel up here, we can actually see it when it's hooked up through the front. We have selectors for current on the 3 main 480 phases and selectors for voltage that we can test them and check the frequency. This meter here is the battery. We can see what the battery power is from the front end. This is the power distribution cabinet. The 3 transformers up here step the 480 3-phase down to 120 volt 3-phase. And we have 1 transformer that just gives us a little bit of power for our lights and some of our auxiliary circuits on there. These 3 coils are for the power cables to go through, and we can measure the current. And they go down to the main switch. This is a 1000 amp switching circuit breaker that goes out to the rest of the world. Obviously, the real wires would be a whole lot larger. Right now, like I say, we're just testing everything, low voltage, low current, to make sure everything works. The 2 big relays here are for starting the generator. It's a locomotive style. It starts in 2 phases. This big relay is what kicks in the master switch. It draws about 30 amps to turn this thing on, and then it holds it on with 1 amp. So this relay makes that switch over from 30 amps to kick it in to 1 amp to hold. And I don't know if you can see these wires on this side, but you notice they're a little bit lighter than all of the other wires that are already in here. That's the wiring that we had to redo, because when they cut it off, you can see places here, they just cut the wires and left stuff with little stubby pieces to figure out how it all goes back together. All right, we've showed you how everything is connected to the engine and the generator. We've got all the cables coming across the floor right now. Like I say, all temporary. This is kind of a prototype to make sure everything works. We got our battery packs. Eventually, they will be under the car and a battery box all sealed away. Got the battery chargers. I'm testing it right now to make sure it does the charge, trickle, and float functions. Then all this goes into our cabinets. Let's go start this thing up now and see what it sounds like. First button I'm going to push is the fuel enable, which turns the fuel disable off on the injectors. But when we have it put together, we'll also turn the fuel pump on. When I push this one, everything's going to get really loud and really noisy. This is going to cause the generator to start. Well, obviously you can tell it's loud. We are contracting to get a high efficiency muffler made. We'll put it up between the roof. There'll be a hole in the roof, let all this smoke and air out. All right, as you can see, we've actually had some pretty good accomplishments this last session. We got the generator in there. We actually got it up and running and started. Well, we have a lot more work planned, a lot more to go. In future episodes, we'll see that. If you'd like to become part of our team, get on our website, join up there. Or if you'd like to donate, any way you can participate with your help would be muchly appreciated.